The diagram shows part of the curve y equals 5 plus root 10x and the line 4y equals 5x plus 20. The line and curve intersect at the point P, which is 0, 5, that's this point over here, and at Q. We're told that QR is parallel to the y-axis. I think that's going to be important later on rather than now. We want to find the coordinates of Q, and that's going to be a case of doing simultaneous equations. So we've got 4y equals 5x plus 20. And we've got y is equal to 5 plus root 10x. So with the x inside the square root like that. Okay, well, let's just substitute 2 in 1 and see what happens. So 4y becomes 4, 5 plus root 10x, and that's going to be equal to 5x plus 20. So we have 20 plus root 10x, sorry, 4 root 10x, equals 5x plus 20, which is quite nice. Subtract 20 off each side, and then we've got 4 root 10x equals 5x, and we can square both sides now. So that would give me 16 times 10x equals 25x squared, and so 160x equals 25x squared. And what can we do with that? Well, we can divide by 5 to start with. So 160 divided by 5 is 32. So 32x equals 5x squared. And then we've got x equals 0, or we can divide through by x, which gives us 5x equals 32. So x equals 0, and the x equals 0 obviously corresponds to this point here, P, where the x coordinate is 0, or x equals to 32 divided by 5, which is 6.4. So then the coordinates of Q are going to be 6.4, and if x is 6.4, let's go back to here. We've got 4y equals 5x, which actually is 32, plus 20, so 4y equals 52, so y would be 13. So it's 6.4, 13. So let's go to the next part of the question. We want to find the area of the shaded region. So what's the shaded region here? Okay, so that would be the area under the curve. Take away the area of this trapezium. Now, as far as the trapezium is concerned, we've just found that this length is 6.4 and the height of this is 13, and P was given as 0.5. So the area is going to be the area under the curve, which is going to be the integral, this is the curve, of 5 plus root 10x and that will be from 0 to 6.4. Take away the area of the trapezium, which is a half the sum of the parallel sides, so that will be 5 plus 13, times the distance between, which is 6.4. So, what have we got here? The integral from 0 to 6.4 of 5 plus root 10 x to the half, and we could probably work that one out now. So 5 plus 13, 18, half of that's 9, 9 times 6.4 is 288 over 5, or 57.6. Okay, so if we integrate this, well, we're going to get 5x there, and then we'll have root 10 x to the 3 over 2 divided by 3 over 2, which is the same as multiplying by 2/3. From 0 to 6.4, take away 57.6. And with the 0, that's just going to give us 0, so it only really matters when we substitute the 6.4 in. 5 times 6.4, well, we know that one is 32. We've come across that a few times in doing the question. And then we've got 2 times root 10 times 6.4 to the 3 over 2 over 3. Take away 57.6, and I think I'm just going to do that as a calculator. So let's have a look. Let's just bring the calculator over here. So we've got 32 add 2 multiplied by the square root of 10 multiplied by 6.4 to the power 1.5. All of that is over 3. Which is, well, if we actually do this, 992 over 15, 57.6. That was 288 over 5. We can actually get a nice fraction out of this rather than a decimal. So we've got 992 over 15. Take away 288 over 5, which is 128 over 15. Square units.